Okay, I think that we are recording both the webcam and the
the
screen. Right? Is that brightened?
It looks good to me, man. It looks
yeah.
it looks pretty snazzy.
Okay.
Yeah.
And action. So have you seen any of these podcasts before where people like talk and
Oh, I've seen a couple. Yeah, it's cool. I like it because it's laid back and at the same time I'm public.
There are
I love public speaking.
There are a couple of people I hope to emulate. So okay, here we go. We're gonna play
How
this.
PG? Swearing? Yes, no?
I mean, I don't know who our audience is gonna be.
PG.
At least 13, you know?
So I can say but I shouldn't say or like...
Dude, I'm gonna edit it out. You can say whatever you want, I'll edit that out. And it's gonna be hilarious. Have you seen Craig Ferguson?
No.
I'm gonna do it like that. Alright, so, you can say whatever you want. Yeah. Okay, don't go overboard. Alright, so, here's what we got. So what we're going to be showing you guys today is some of the work that I did on, make sure we get our Disturbed playlist going. This is some of the work I did a couple of days ago. I was trying to recreate this back turret plate here, because what I have right there is what's called a loft feature, which works really well and looks nice, but it means we can't manufacture it. Oh, you know what? Let's introduce ourselves.
Let's do that.
Because no one knows who we are.
Let's do that.
I'm Beckett. I'm part of the Project38 engineering team. Most of the AutoCAD and Inventor files you see up on the website are my work, as well as Nathan. He's not here today. And this is Seth.
This is Seth Pendleton. You guys haven't heard from me much yet, but I've been in the background for everything that's been happening. I've been talking to Beckett. I've been talking to Tristan, his brother. And, you know, it's just a really cool thing. Like I said, you guys haven't heard from me much, but I'm here, and you're going to continue to hear from me as we progress. My skills are marketing. I'm a pretty decent salesman as far as I can tell. I love this project.
This guy's going to be like the face as we go out and be obnoxious.
I really hope so. I mean, I'm right here being the face of this. I guess you could say it's a blog, kind of. It's just a live stream blog. Well, not live.
Commentary?
Commentary.
Yeah, we're doing a commentary.
Yes, my bad. It's not a live stream. I have a face for that kind of stuff. We should, actually.
No one would watch.
I totally agree. No one would watch,
No
but
one
that's
would be
okay,
watching.
because we would get that one view, like 30 seconds in, and we go, hey!
Right, exactly.
And then he would quit, and then we'd be like, well...
It'd be my dad on dial-up.
Be like, hey, everyone we know, please, just start watching this, just so we feel like we're kind of bored.
We'll be like, watch my video, please.
That's my whole thing. I'm Seth Pendleton. I'm really relaxed. I have a beer.
Yeah.
Beckett has a beer, and by God's good grace, you have one too. So, cheers to that.
Yeah.
Let's watch this video and let's see what we got. All right.
So what's going on right now is I am. I think at this point I'm trying to recreate the file that I had earlier on. Because you see, I've got the cylinder frame. Because what I did was I created a cylinder and put a 10-degree draft on it. Which sounds really complicated, but this is really cool. Inventor's simple enough to do that. So here I'm basically recreating the measurements that I did. By the way, guys, I'm super proud of the work that I did on this back plate, because it's like, it was really, really complicated. It's working in 3D space. There's no right angles. There's like curves and cones and random sections and intersections.
Hard stuff to engineer, basically.
Especially on my skill level. I've been doing this for about 2 years. It is. It was though. It was really hard. Yeah. Especially because I could make it look right, but can you make it look right and manufacturable at the same time?
This is years in the making right here.
Oh my gosh.
It's actually incredible. I was talking to someone earlier at the bar when I got off work about it, and she was absolutely blown away. Couple of them were, actually. It's just really cool.
Good. Yeah.
Best part about that is then you have people who listen in, especially when the bar is super quiet and there's maybe like 2 or 3 other people having a drink, and they listen in and they're like, what were you talking about?
Who's building a tank?
So that's my skill set. That's what I add to Project 38. I go to the bar, drink, and talk about the tank. Yeah. And it just sort of works out.
All right. So check it out, right? Remember earlier I was getting measurements off of that old part? Well, here's that part 2. You see I've got part 2 here. Here's the new one. I'm like, all right, it's a measure our radius, measure our angle, and we're gonna go from there. We're gonna hopefully create this properly the first time. You can see some of the programs I got running in the background there too. So you know, we know that it's a 15 millimeter plate, so I create that. I think I messed up a couple of times here. It's been a while since I've watched this video. I think it's been like a week since I created this. This was part of an endeavor to make sure every single plate that we made was a something we could put into a flat pattern. Basically, take your cone. I got a piece of paper or something. All right, so here, take my bills here. We have your turret plates at like a bit of a cone section. We have to be able to flatten that out, and because it's all coming out of sheet steel, and we do want to make this out of 15 millimeter plate, which is what the original had. I still don't know how we're gonna manage to manufacture it. Hopefully we can. Oh my gosh, this is beautiful. Hopefully we can get somebody to like donate their heavy forge, go to Lehigh Heavy Forge, and see if they want to like do it at cost or something. But okay, so here we go. I got the Revolution. I want to skip back a couple of seconds here, because that was a really cool feature. What I did, I just extended it all the way up because I didn't know how tall the plate was yet. I don't know how tall it is, but I know the radius and I know the angle, and because I know those two things, I'll go and create a Revolution, hit revolve, did full. I was like, all right, I know it's not full, but I know somewhere in that cone is the piece that we need. So I just did 90-degree revolution. I think I edited that. And now I have to figure out, okay, how far across, how far around is this going to go? So I spin around a couple times. And look, there it is. It kind of looks like what I need, but it's really not.
It looks a little lopsided at this point, I think.
It's a little lopsided and way too tall. Like,
yeah.
This would be making like a KV2 kind of oof, Yeah. But check it out. I go to the old part. I'm like, what's the angle? So I just... what is the angle? And it's so ghetto the way I did this, actually. There's no reason why this should have worked, but it didn't, actually. And you'll see later on, this didn't work at all. But it got me close enough. Honestly, like... Later on, I found out that I'm gonna be cutting this down anyway. So
what you're essentially making right now is my nightmare from sophomore year geometry class.
Oh my gosh!
It's like honestly, I should have paid more attention because at this point, if Beckett Evans could program one tank to do basically anything,
we have our skills. You have yours. I have mine.
Dude, he's just like the group mad genius.
I'm definitely mad.
He was definitely mad.
See, I got this 51.24 degrees. I mirror that, and it turns out to be wrong. But we'll find that out later why it's wrong. Actually, I don't know why it's wrong. I think we'll find out. Okay, so here's the next challenge. We know that there's a cut, like at 9 degrees off from flat, and somehow I have to figure out how high this work plane is, and how and where I need to position, because I know it's somewhere like somewhere here.
Okay.
And I need to know how high it is and what the angle is, and
okay,
how far in it is. So here I'm creating a sketch. So I create 2 work planes, and it's like, okay, there's the angle right there, right?
Yeah.
So let's figure out where the heck that is, because I know it's there, but how can you recreate that? You're like, okay, so you look over here and it's 9.01 degrees, which, by the way, that number becomes really obnoxious later in my life.
Let's explain that further. Not yet.
Well, it's supposed to be 9 degrees. It's supposed to be 9 degrees, and I'm not sure where the 9.01 comes in. I think it was created when I cut this off of my original design. Because I use it using reference geometry instead of building it from scratch. So it was basically, hey, make it look like this, about. And Inventor did admirably.
Perfect. How many times did you have to say you used 9.01?
0. I don't ever want to use that number again. No, some of the geometry in this tank has been bafflingly not normal. Like
it's great too, just because of how early of a tank it was.
Yeah.
Like it's simple.
Okay, yo,
Everyone
check it out.
says it.
Check it out. I'm doing a fit test. I'm gonna see if it works, right? Right. So this whole time we've been talking, I've been working on things. And by the way, can you just appreciate how gorgeous that is? I'm gonna do a fit to the cone, right? Because there's a conic section right here. Oh, hello. I can't maneuver the program.
So why are you? Let's talk about why you were at that angle. Why are you so far out? You were trying to fit it as it was that far out. I'm curious why.
Just because Inventor's confusing sometimes.
Okay.
No, I I needed to maneuver in a way that would make more sense if I was far away. Because, like, I'm trying to fit it to the cone that is created by the two side plates to create its orientation, so it's not sideways, it's right upside down.
Okay.
And that didn't work. So I tried something else. And I think at some point I come up with a couple of errors, like, you're wrong, you know, kind of errors. But we'll find out. So as we go along, I mean, it looks pretty good, you know? I'm pretty good, but
I'm happy.
But now I'm like, well, crap. How the heck am I going to create the angle between those two plates? Like,
holy fuck,
it's a 10-degree draft on an angle. Like, how? Oh wait, that's how I'm going to do it. It's a 10-degree draft on an angle. So yeah, I have no idea how I ended up making it fit properly. Because at this point, at the point of recording the video, that plate is fully defined in the assembly, and it fits really nice. I mean, actually, this 3D print,
it looks nice.
Was
really
created using that back plate, right? Which I need to finish the top of this thing at some point. So there's so many things I have to do. I don't know. I never realized how much went into a project like this until I started doing it myself. Yeah. But come hell or high finances, I will finish this thing.
Hell or high finances.
And there's gonna be.
Let's start with finances.
Yeah, let's start with finances.
We can worry about hell later.
No, we've already got that. Okay, did you see what I did there? I just put in 9.01 degrees. I don't know if you saw that.
Go back and look at it again.
You know what's funnier than 9.01 degrees? 91.
25.
25. Okay. Yeah, because I knew that the angle, in order to constrain it, I had... There you go, right? I'm going to try and constrain these two plates together.
Yeah,
boom, and it totally didn't work. Assembly cannot be solved. It basically told me to go myself. Dude, this is like half an hour of work for this one plate on the back.
That is so annoying. See, my mindset tells me, okay, Seth, obviously from the top here, from the top of the screen, that one piece looks like it's already skewing out. I would just
it's already so jacked up.
I would just take a saw or some kind of shit and just cut it off, but that's not how it works.
Well, that's
not how it works. Because did you use that same piece fit into the rest of the design?
Later it will. So I'm trying to put it together, ready, and let's mate this one last time. This warning I get all the time because it's just I'm a terrible engineer. Okay, come on, Beckett. Try and make it work. We're gonna constrain this flat surface and make it concentric with that. And enter. Assembly cannot be solved.
Incredible.
Yo, this is the bane of my existence because so many of my parts are just like I can see that they're properly built, but because it's 9.01 degrees instead of 9 degrees.
That great number.
Okay, see, check it out. Here I've got, I think I put both plates on.
Yeah.
No, I didn't. You see, there's a little lip there. I'm trying to figure out, where does that lip come from? I'm like, well, if I slide the plate backwards, forward, backward.
It looks nice from this angle, but then you go.
But then look at the gapping. Yeah,
Yep.
gapping. Yeah. So this is the kind of thing I'm like trying to figure out. Okay, how did
just make another piece and stick it in there?
The numbers are right. Why is this so wrong? I'm trying to figure it out.
How long does this take exactly? How long did you spend in real life? How would you say how long did you actually spend trying to figure this out?
On this particular plate, I spent 33 minutes 44 seconds and a half on it. And you can tell because that's how long the screen cap was.
Okay.
On other parts, I've spent hours. Yeah, so there you have it, folks. A little bit of insight to Project 38 and our nonsense. Hey guys, this is Tristan. Thanks for watching. We'll be putting these videos out hopefully monthly, and just stick around, let us know what you think, let us know how to improve, and we'll see you next time.